Question number 1. Which of the following is not a measurement obtained using one of the laboratory measuring instruments? There are 5 measurements. We can consider third measurement 45.73 centimeters. There are 2 decimal places in the third measurement, but it is in centimeters. There are 2 decimal places in centimeters. It means 0.1 millimeter should be least count of the instrument for the reading corresponding to the third one. Therefore, it should be vernier caliper, but we know that we can't use vernier caliper to measure a length like 45 centimeters. It is a large measurement. Therefore, third answer is the question number answer for the question number 1. Question number 2. Figure shows the main scale M and vernier scale V of a measuring instrument. We have to find the least count of the instrument. The question is not completed in the PDF, but you have to understand we have to find the least count of the instrument. And there is a problem related to given figure. The figure should be like this. Vernier scale in upside, therefore 10 to 20. 10 and 20 should be coincide with parts of main scale. It is not clear in the diagram, and there are 9 main scale parts coinciding with 10 vernier scale parts. Then we can consider they have given in this side it is in millimeters. Therefore, main scale is in millimeters. 1 millimeter part 9. Then length of this part is 1 into 9 millimeters. Should be equals to. I will consider vernier scale part length of a vernier scale part as x. Then x into 10. Then we can find the value of x. 0.9 millimeters. This is the length of a vernier scale division. And we know that for the vernier scale, least count is vernier scale division minus, main scale division minus vernier scale division. We can consider main scale division 1 millimeter, vernier scale division 0.9 millimeters, 0.1 millimeters. It is the least count of the instrument. Then we can get 0.1 millimeter. Second one is the correct answer for the given figure. Then third one, the figure shows a part of micrometer screw gauge at a time when its 2 jaws are in contact. The zero error of the instrument is. We can consider scale, main scale and circular scale of the instrument. Main scale 0 is not in the diagram. It means we can't see it because of circular scale 0 is passing this 0 has passed this space, and therefore we have to understand this is a 0th error, and we have to add the 0th error to the reading obtained by the instrument. The 0th error like this, we can get 0th error equals to least count into, there are 50 parts in the circular scale. We have to multiply by 50 minus this coincided part. It is 2. 50 minus 2. Then 50 minus 48. 48. Because of they have given this part is 45, 46, 47, 48, 49, again 50 means 0. Then least count of the micrometer screw gauge is 0.01 millimeters. We have to multiply by difference of these two numbers to 0.02 millimeters, and we have to add it to the scale reading. Then we can get third answer for the question number 3. Then question number 4. The figure shows a part of micrometer screw gauge when the jaws touches each other. The zero error of the gauge is. It is like same as this diagram, but there is a small difference between this diagram and given fourth question. It is coincided part. Coincided part is 45, 46, 47, 48 in this diagram. For the fourth question, 47 is coincided part. 45 is this part, 46, 47. Then we can get zeroth error by using same method. Least count 0.01 into 50 minus coincided part 47. Then 0.03 millimeters is the zeroth error for question number 4, and we have to add the zeroth error to the corresponding reading we can obtain by the instrument. Then third answer is correct for the question number 4. Then question number 5. If n minus 1 number of main scale divisions of a certain measuring instrument is divided into n vernier scale divisions. There is a problem in question, n vernier scale divisions. Then the least count of the instrument in main scale divisions. They have given that n minus 1 number of main scale divisions. N minus 1 number of main scale divisions are coinciding with n number of vernier scale divisions. I will consider length of a vernier scale division is x and length of main scale division is 1. Then we have to find the least count of the instrument. When finding least count, we have to find this x value. We can consider length of main scale division, main scale length and vernier scale length between these two coincided parts. These two coincided parts. Then main scale length is 1 into n minus 1. It should be equal to x into n. Then we can find x value n minus 1 divided by n. It is the length of vernier scale division. Then we can find least count is main scale division minus vernier scale division. Main scale division is 1 minus vernier scale division is this value n minus 1 over n. We can simplify n times n minus 1. Then we can remove bracket n minus into plus minus n minus into minus plus 1 divided by n. 1 over n is the answer. Then question number, then answer is second one for the question number 5. Then question number 6. The length of a rectangular wooden block W is measured using a vernier caliper. The figure shows the relevant sections of vernier calipers and block. Only relevant divisions in the vernier scale are shown. If there is no zeroth error in the vernier caliper, then the length in the wooden block is. We have to get the reading directly. We can consider main scale reading. When considering main scale reading, we have to get main scale part before the zero of vernier scale. Zero of vernier scale. Then before zero of vernier scale in main scale division is 14 millimeters. 14 millimeters. Then we can get reading is main scale reading plus least count into coincided vernier scale part. Main scale reading is 14. We have to add least count 0.1 millimeters for the vernier scale and 0.05 millimeters. It is given in the question. See the right hand corner of given instrument 0.005 centimeters, but I am considering millimeter value, therefore we have to multiply by 10 to convert centimeters to meters. Then least count is 0.05, and coincided vernier scale part we can identify clearly in the diagram. It is 10th part. Then 14.5 millimeters, it means 1.45 centimeters. Then the answer is third one for the question number 6. Then question number 7. The most suitable measuring instrument to measure the external diameter of a soft rubber tube having its value of order of 1 centimeter is. We know that if we are measuring the external or internal diameter of a rubber tube, its shape is differing. Therefore, we can't use vernier caliper, spirometer, micrometer, screw gauge to get the reading. We can measure external and internal diameter without touching the rubber tube by using Tavelin microscope. Then we can use Tavelin microscope to get the reading. Then answer is 5 for the question number 7. Then question number 8. The following measurements A, B, C have been taken using correctly selected measuring instrument. A 3.1 centimeter. There is only one decimal place in centimeters. It means least count should be 0.1 centimeter or 1 millimeter. We know that it is a reading of meter ruler. Then A is the reading for meter ruler. Then B 4.23 centimeters. 4.23 centimeters means there are two decimal places in centimeters. It means there is only one decimal place in millimeters. Therefore, it should be a reading obtained by vernier caliper. Then third answer 0.354. It has three decimal places in centimeters. Then there are two decimal places in millimeters. Therefore, it should be obtained by micrometer screw gauge. Then meter ruler, vernier caliper, and micrometer screw gauge. Answer 4 is correct for the question number 8. Then question number 9. The percentage error of a certain length measurement has to be kept below 1%. If the error due to the measuring instrument is 1 millimeter, the measuring length has to be greater than. We have to consider equation for the percentage error. We know that percentage error equals to maximum error, it means least count divided by reading multiplied by 100%. I will consider percentage error as 1%, least count 1 millimeter, it is given in the question. We have to find the reading. Then reading is 100 millimeters. 100 millimeters means 10 centimeters. Then answer 3 for the question number 9. Then question number 10. Figure A shows the scale of a micrometer screw gauge when spindle and anvil touches each other. Figure B shows the scale when metal sphere is properly placed between spindle and anvil. The pitch of the screw is 0.5 millimeters and the circular scale is divided into 50 equal divisions. What is the correct diameter of the metal sphere? In first diagram, there is a zeroth error. We have to consider it. Coincided circular scale part is 1, 2, 3, third part. Third part, and the scale is like this. It is like this. It is the third part. Therefore, this is an error. We have to subtract from the reading obtained by the instrument. We can get zeroth error. Please count 0.01 into coincided part 3, 0.03 millimeters is the zeroth error. Then I will consider second diagram to get the reading. Main scale reading is 3.5. Main scale reading 3.5. We have to add 0.01 into coincided part is 31. Then we can simplify it, 3.81 millimeters, and we have to subtract this error. Therefore, corrected reading is 3.81 minus 0.03. 3.78 millimeters. It is the correct diameter of the instrument. Then third one is the correct answer for the question number 10.